What if one of the closest black holes to Earth was never found by light, explosions, or X-rays, but only because a nearby star was trembling for a reason no human eye could see? That is Gaia BH1. A dead object about 10 times the sun's mass, roughly 1,560 light-years away, orbiting with a sun-like star that looked almost ordinary until precision data exposed the lie. And I think that is the unsettling part. Not that black holes exist. That one this close could hide in plain sight. Gaia BH1 matters because it was the first black hole confidently confirmed through the tiny orbital wobble measured by the European Space Agency's Gaia mission, without needing the black hole to glow, feed, or announce itself through violence. In other words, the galaxy may be quieter, darker, and far more crowded with invisible remnants than we were comfortable imagining. For years, most known stellar mass black holes were found because they were messy. They stole gas. They heated that gas until it blasted X-rays into space. They behaved like cosmic crime scenes with fingerprints everywhere. Gaia BH1 did the opposite. It left almost nothing. Just a star moving in a way that made no sense. That is the what? A black hole you do not see directly, revealed because its companion star was tracing a slow gravitational dance. The how is where this becomes almost absurdly delicate. Gaia tracks star positions with precision down to micro arcseconds. That is like noticing the width of a human hair from thousands of kilometers away. A wobble that small can betray an invisible mass. The star in this system, cataloged as a sun-like G-type star, did not look like a victim. It was not being shredded. It was not glowing in X-rays. It was just orbiting something massive every 185.6 days. When researchers combined Gaia astrometry with radial velocity measurements from ground-based telescopes, the hidden companion came out to about 9.6 solar masses. Too massive to be a normal star, too dark to be anything but a black hole. And that process matters more than the object itself. Because if you can find one invisible black hole this way, then suddenly you are forced to ask a much more uncomfortable question. How many more are out there, attached to perfectly normal stars, drifting through the Milky Way while we stare right past them? Personally, that question gets under my skin. We're used to imagining danger as something loud, a supernova, a gamma ray burst, a jet of radiation. Gaia BH1 is disturbing for the opposite reason. It suggests the universe can hide enormous things behind ordinary appearances. A calm yellow star, a routine orbit, and beside it, an abyss. The story became public in 2022, led by Kareem El-Badri and collaborators, after earlier black hole candidates identified in Gaia data faced heavy skepticism and even collapsed under reanalysis. That skepticism was healthy. Astronomy has seen false alarms before. But Gaia BH1 survived because the evidence stacked from multiple directions. Precise astrometry, spectroscopic velocities, and orbital modeling that all converged on the same answer. Which is almost funny in a dark way. Humanity did not catch this black hole because it screamed. We caught it because a nearby star flinched.
What do you think is more unsettling? A black hole that
blazes in X-rays, or one like Gaia BH1 that stays completely dark and only gives itself away through a tiny wobble? Tell me in the comments. There is another layer here that makes Gaia BH1 even stranger. According to older expectations, a system like this should have had a violent past. To make a black hole, you need a massive star to die. That death often disrupts binary systems. It can strip, scorch, or even eject the companion star. Yet Gaia BH1's companion looks remarkably normal. Not heavily polluted, not obviously mangled. That means either the system formed through a gentler route than many models assumed, or our models of black hole binary evolution are missing something important. And this is the thesis I want to leave with you. Gaia BH1 was not just the discovery of one black hole. It was a warning about observational bias. We have been building our map of the galaxy from the objects dramatic enough to expose themselves. But the Milky Way may be shaped just as much by quiet remnants that do not shine, do not feed, and do not cooperate. The census may have been skewed from the start. Estimates for the number of stellar mass black holes in the Milky Way often range from about 10 million to 100 million. We have only identified a tiny fraction. Think about that scale in human terms. It is like trying to estimate the population of an entire continent after meeting a few dozen people standing under street lamps. You would not just be incomplete, you would be deeply misled. But this was only the beginning. If Gaia could uncover BH1, then the mission was no longer just a star catalog. It became a detector for absence, a machine for finding gravity without light, and that changes the search itself. Astronomers no longer need to wait for a black hole to feed. They can look for what it makes something else do. Gaia measured positions for more than 1 billion stars. Its Data Release 3, published in 2022, opened a flood of orbital clues. Every tiny deviation becomes a possible story. Unseen star, brown dwarf, giant planet, or something much darker. That is why now. Not because black holes are new, because our instruments finally became precise enough to notice the whispers. Confession. When I first read about Gaia BH1, I did not feel fear in the movie sense. I felt a quieter kind of vertigo. The kind you get when reality turns out to be less visible than you thought. Have you ever realized you were trusting your eyes too much? Astronomy has been teaching us that lesson for centuries. Gaia BH1 just made it personal. It is not across the observable universe. It is in our broader neighborhood. Tone shift, building. Urgent. But wait, there is a twist almost nobody feels on the first pass. Gaia BH1 is not terrifying because it threatens Earth. At 1,560 light years away, it does not. The real shock is worse for our ego. It means one of the nearest known black holes was sitting close by in galactic terms, and we still missed it until a spacecraft measured a stellar wobble too small for human senses to grasp. That reframes the whole galaxy, not as a glowing atlas of known objects, but as a landscape where the invisible may outnumber the visible in crucial ways. The dark remnants are not exotic intruders. They are part of the normal architecture of the Milky Way. They shape orbits. They preserve the memory of dead stars. They drift through stellar regular neighborhoods without a trace of light. Can you imagine how many ordinary stars might be circling something like this right now? Can you imagine how many systems we have mislabeled as simple because nothing dramatic was happening? There is also a scientific humility in Gaia BH1 that I love. The discovery says the universe does not owe us fireworks. Some truths arrive as tiny residuals in a data table, a line in a velocity curve, a positional drift too small to notice without years of patient measurement. In my opinion, that makes the discovery more profound, not less. It tells us that reality is often revealed by precision before spectacle. If that idea surprised you as much as it surprised me, that one of the closest known black holes was exposed by a star's tiny tremor and not by light, leave a like, because the next detail makes this quiet system even more important. Gaia BH1 also pressures theorists to explain survival. How did a sun-like companion make it through the death of a massive star without obvious devastation? Some scenarios involve direct collapse, where the progenitor star may have formed a black hole with less explosive disruption than a classic supernova. If that channel is common, then the galaxy could be full of black holes born with much less chaos than we expected. And if that is true, then Gaia BH1 is not an oddity. It is a hint. A doorway. A first clear member of a hidden population that was always there, just beneath our detection threshold. You see the existential punch now. The Milky Way is not only stranger than we imagined, it may be stranger in ways that look completely normal until measured with absurd precision. There is something almost poetic about that. One star, moving by a fraction. One spacecraft, patient enough to notice. One dead object, perfectly dark, finally forced into the open, not by what it emitted, but by the silence it imposed on everything around it. That is the payoff. Gaia BH1 changes our picture of the galaxy from a museum of bright objects into a forensic map of hidden gravity. It tells us the cosmic backyard is not empty just because it looks calm. It tells us invisibility is not absence. And it tells us that some of the most important things near us may remain unnoticed until something small, patient, and almost imperceptible gives them away. So the next time you look at a quiet patch of stars, remember this. One of the nearest black holes we know was hiding beside an ordinary sun-like star, waiting for a wobble to betray it. Not all predators roar. Some bend space in silence. If the invisible architecture of the universe fascinates you, subscribe and join me here. This galaxy is full of things that do not announce themselves, and we are only beginning to notice where they have been all along.